This podcast covers the work energy theorem. First of all, we need to know about kinetic energy. That is seen up here. Kinetic energy is the energy that something has when it's in motion. It equals 1/2 times the mass of the object times its speed squared. Like work, kinetic energy is measured in joules and it is a scalar. The work energy theorem says if you add up the work done by all of the forces on an object, that equals the change in kinetic energy. The final kinetic energy minus the initial kinetic energy. You can also think of it as calculating the net force on the object and finding the work done by the net force. Here are some examples of problems with kinetic energy. This one says, if the kinetic energy of a particle is tripled, by what factor has the speed increased? Now, this is one of these problems that doesn't have as many numbers in it that sometimes bother students, but it's really not a hard problem. The initial kinetic energy, K naught, is 1/2 mv naught squared. The final kinetic energy, K, is 1/2 mv squared, where v is the final velocity. And it tells us that the kinetic energy is tripled. So the final kinetic energy equals 3 times the initial kinetic energy. Now I'm going to plug these expressions in for K and K naught. K is 1/2 mv final squared. That equals 3 times 1/2 mv naught squared. And you can see in this equation several things are going to cancel. If we multiply both sides by 2, the halves cancel. Divide by m, the masses cancel. Now I'm just left with v squared equals 3v naught squared. Take the square root of both sides. V equals plus or minus the square root of 3 times v naught. Now if I'm thinking of v as just the speed, we don't have to worry about the sign. We can just say v equals the square root of 3 times v naught, because the speed is just the magnitude of the velocity. Here's a second one. This one says the speed of the particle is halved. By what factor does the kinetic energy change? Now this time the speed of the particle is cut in half. So the final speed is 1/2 of the initial speed. So if I write the kinetic energy, the final kinetic energy is 1/2 mv squared, but I plug in 1/2 v naught instead of v, I get 1/2 m times v naught over 2 squared. When I take away the parentheses, that 2 in the denominator gets squared into a 4. So this is 1/2 m v naught squared times 1 over 4. This part is the same as K naught. So this equals 1/4 K naught. So if you cut the speed of a particle in half, the kinetic energy decreases by a factor of 4. Now the work energy theorem. You're driving along the greenway when you notice a police car 500 meters away. You look at your speedometer and see that you're going 36 meters per second. The speed limit is 29 meters per second. In a panic, you slam on your brakes and try to reduce your speed. What braking force is needed to reach the speed limit by the time you reach the police car? The mass of your car with you in it is 1,500 kilograms. Use the work energy theorem. We're trying to find the force, and we know that the formula for work equals F d cosine theta, has force in it. So we're going to use the work energy theorem to find the work, and then we're going to use the definition of work to find the force. So we're going to find K and K naught, take the difference, that'll give us the work. K naught is 1/2 m v naught squared. That's 1/2. Our mass is 1,500 kilograms. 1,500 times v naught is 36 meters per second squared. And if we plug that in, we get, oh, I didn't write it down here.